Hi, I'm Dave Burrows from Roads and Rails Museum. I'm the guy here who does most of the electronics work. I have no educational background in that area, but I had to learn quick when we got started trying to build one of the area's most popular attractions. And the story of Roads and Rails really is a story of wire. We have over a mile of wire here, and we've got microprocessors underneath the layout. We have numerous electronic timers and motion sensors so that items only come on when people are interested in seeing them, and otherwise the motors can rest. And over the next few days I'm going to be doing the maintenance on this, and I'm going to film as I go and describe what we have here and the rationale behind it. And I hope you enjoy this. Thank you very much. Hi, I'm Dave Burrows, and this is the underside of Roads and Rails Museum. This is my kingdom. This is where all of the wiring is done, and I've done quite a bit of modeling and set building as well. But this is almost all exclusively mine, except for a few elements. And we have over a mile of wire under here. It's color coded. It's tagged extensively, and we can come under here and do improvements and maintenance even when the museum is open. And we have a lot of microprocessors, timers, home automation, particularly motion sensors that turn on various things at various times, sometimes because a person is present, sometimes because they push a button, and sometimes simply we have timers set up to reduce the wear and tear, so they're on and off an equivalent amount of time, so that users get to see them, but they're not worn out by running all the time. And I'm going to show you what it's like under here. It's pretty cool. Okay, 2 years ago, I installed our first Arduino here at Roads and Rails Museum. Arduino is an educational platform. They call it a prototyping platform. And you get a 80 mega chip, and you can read about it online and get much more accurate information than I'm able to give. But basically it allows me to program it by a computer, burn it onto this chip, and then use it to control relays and take in input. Now, I wildly overbuilt this one. This animation only requires 3 relays. I've got 8 right here. I built my own shield, which I could have just bought off. I could just simply have bought one. And I put this, again, we got this terminal plate from the Bell telephone box, and I have, we route all kinds of stuff to it. We run it off of what we call a wall wart, an AC adapter. We buy our AC adapters from American Science and Surplus, and they usually can get them pretty cheap that way, much cheaper than in the stores. And the great thing with the Arduino is it's very tolerant of amateur electronics builders. I am not an electrical engineer, and it's very tolerant of the kind of mistakes people make. Now, it'll shut down, of course, if you make one of those mistakes, but it won't burn the chip through. So it's actually very nice for that purpose. A lot of people use, for example, the Raspberry Pi, which is the next step up from the Arduino. They will put an Arduino between the Pi and what they're trying to control, because the Arduino will shield the Pi from the kind of problems that the Arduino will be able to survive electronically. So I'm still proud of this. I've got what I did is that we have an MTH animation, Mike Strainhouse. It was very slow because it was more like a clockwork kind of, almost like one of those old clocks, and it was Mel's Drive-In. Girls come out, cars come around, people are served, and the girls go back into the building, and the car pulls back. Ours stopped working, and it was worn out after 1 year of service, because a very intense service. We left it on all the time while the shop was open. And the reason we did that is because if you pushed a button, it was just too slow to amuse people. And so what we did is we we pulled out all the old motors and put new motors in. And in the course of that, I was using the same brain that came with it. Well, that brain died. I fried it, and it was huge smoke and everything. So that's how I got into the Arduino. I actually went down to the Radio Shack thinking I'd buy the basic stamp. This is how little I knew of the Arduino. And I learned about the Arduino, and then we've used it for various things around here. Anything that requires a little sequencing or a little decision making. And most of the decision making is when someone pushes a button. But sometimes we have sensors. And I will show you one of those things in a few minutes. Still looks nice. This is a second Arduino, and what this one does is it actually uses two sensors by the Bosch company. Bosch is a German electronics company for model railroading, and we use this to control the trains stopping at the main station. And as you can see here, that is, you can't see the Arduino. It's underneath what you do see, which is called a shield. In this case, it's a relay shield, and I had to actually work with it to put the sensor inputs on it, which are at the top. And this saves me the trouble of having to do what I did with the last board, which is to make my own, to build my own circuits for the to run relays. This one does that for me automatically, and it also, in addition, isolates that from the board. What goes through the power that is controlled by the relays doesn't interfere with the electronics on the Arduino board. It's shielded, and that's actually a very good thing and very necessary in most cases. Now, I would have done this differently now. I would have used ultrasonic sensors. But we had these Bosch sensors. We had bought them. There's the Bosch right there. Let me get some more focus. And that right there, as you can see, that's hanging down, is a relay that goes to a terminal block that goes to one of the Bosch infrared sensors. They're infrared sensors, and when something passes between the light and the infrared electric eye, it trips it off. And we have another one. I'll see if I can get to it. We have another one over there. You can see right here. You can't see through the massive wire we have hanging down, but there it is. And all this is low. Before people who write in about our electrical work, these are all about 18-volt maximum wires. They're really low. Most of them are carrying less power than your average battery-powered flashlight. They're very low power. And this relay right here, I pointed out before, this is actually another one I harvested from the Bell telephone box. So I used two of them here, and it's a good thing. It saves us a little money and makes us feel a little bit more clever than we would otherwise.